Now, I tell the truth, AI has a little breakthrough at all. It's a cheating and unethical.
Welcome, Dr. Wang. Thank you for joining our channel. Please tell us a little more about yourself and your background with AI.
It's my pleasure to give the first talk on this channel. I am a scientist, a retired professor from Michigan State University, and my home department is Department of Computer Science and Engineering, and I got degree in PhD in computer science at the University of Illinois, Urbana-Champaign. And right now I retired, but I still do research and also other things after the retirement time. It's my pleasure to talk about something that you are interested in.
What are your thoughts on the status quo of AI right now?
So AI is very, very popular right now. Almost everybody is interested in AI. And I have a professor in Macau, and he is the president at that time. He said that, John, who is not interested in AI? Even my wife and my son, they are all interested in AI. What happens? AI has been around for many years. And what is going on right now is the popularity. We heard a lot of media hypes. Now, I tell the truth, because I'm in this field, the AI is popularity improved, but AI has a little breakthrough at all. And we had a huge problem. The problem in the sense that we did not tell you the truth. So we in AI field, working in AI research and development, but we did not tell you the truth. My estimation of the future is that the AI will go down, go back to status quo, and we will lose a lot of money, investment money, if you already put money in AI investment.
You mentioned there's a problem in AI, and I'm interested what the problem is. Could you explain it to us and our viewers who might not be as technical in AI?
This is a very good question. So what I said in terms of AI is not doing very well instead of its popularities. The problem is what I called post-selection misconduct. What do you mean by post-selection misconduct? Post is P-O-S-T, selection is a misconduct. So it consists of three things. The first is cheating. The second is hiding. The third one is exaggerations. And post-selection is a misconduct. And I will probably talk a little bit more about the post-selection misconduct. It is like you are doing chess game. Post-selection is like, I see your move, next move, then I regret. I select my moves according to your move. So that's a cheating. That's a cheating. And I can talk a little more about that once we have more questions coming up.
So why does this problem come in the first place? What kind of decisions lead to these issues in AI?
This is not something that people like doing robbery. Robbery is like on purpose. I rob a bank, I plan it. Post-selection is most likely come up naturally. Give example that if you do not know statistics well, then I try to do something that in a very intuitive fashion. So give example, when you play chess, and I see that, oh, you haven't moved, and I regret it, and I start to argue with you, and I want to say, I want to regret, I want to change my move because I know this is cheating in computer chess, even in a natural chess. It's cheating. But it's very natural because I made a mistake. So post-selection is like, oh, I had a system, I trained it, but did not do very well. And I tried another system, and I look at whether it did well or not. And the more I tried it, more lucks I have, and then I have more options. So this is called post-selection, means that I see the performance. After I see the performance, and I select which system I want to count on. So this is a post-selection. It's a cheating, but not necessarily that you want to cheat a friend, like you want to rob a bank, but rather you decide after you made error. So post-error, you try to change your decision. So that's very natural, but unethical.
That is interesting. I'm curious, what are the repercussions of these decisions if this error is left unchecked?
Very good question. So what's the drawbacks? Suppose I drive a vehicle and I already made a mistake, so somebody came up to block me and I did not see it. I ran into that guy and I'll probably injured that guy or even killed that guy. I already made an error. Can you regret? Of course I regret, but damage is done. So in the real setting, you do not have a validation set, I call it. Validation is like mock exam. Your teacher gives you a mock exam, and you can see whether you are doing well or not without much cost because your teacher knows the solution for the mock exam. I call the validation set. The validation set is like mock exam, M-O-C-K. But in the real world, you don't have luxury of the mock exam, so you don't have a chance to decide which system in your bag does the best. You don't. Because you tried one system only, and if you already run into traffic accident, you killed somebody, it's already happened. You cannot say, oh, I regret. I have another system in my bag that probably does better. No, that is not acceptable. The damage is already done. That's why driver's car is not doing very well. Many big companies, I don't want to mention the name, you know it. Many companies get a lot of money, invest money. They are doing that, but there are some small scale constraint areas they do testing. But after a while, you can see that it does not do very well because we already have cases that a lady was killed in California. So the thing, like accident will continue, mistake will continue to be made, and many development teams will not publish their record, and it keeps burning the money, invest money. And the AI is not doing very well because of post-selection problems. If you made an accident, it will be damage. It's already done. You cannot post-select your system.
I'm curious if there are tools or ways to detect these issues in AI models. What was your way around? How did you discover this?
So there are many ways of testing AI systems. Typically, it's the error rate. And the error rate is like, suppose you have like 100 decisions to make, then the error rate is that among the 100 decisions, what's the percentage of the errors? Suppose you have 100 decisions and those are correct and those are wrong and binary. Of course, it does not have to be binary, but let's consider non-binary. Correct or wrong, then suppose you have, say, 40% to be wrong, 60% to be correct, then your error rate is 40%. But that's like a case where you have a validation set. Validation set you can measure it's 40% wrong and 60% to be correct. But in real world, and you just cannot afford to make any errors. Like driving, if you make error, you may damage your car, or you get a traffic violation and you get ticket. All those are very, very costly, especially driving. In this sense, that in real world, You have small errors, and human make errors. You get traffic accident or you kill somebody, and major mistakes, they probably go into jails. But in real situation, the test is very different from the computer simulated test using validation set. That's very different. In a real setting, and everybody make mistakes, and small mistakes, like you get a ticket, and huge mistakes, you get into the jail. It's very different. Very good questions.
Yeah. For somebody interested in AI, especially our viewers who want to learn more about AI, how can they be more aware about this issue? How can they learn AI the best way?
Now, you're talking about the best way, and many people hope that. And there are no best ways because it's like try and error. And it's like you don't know the best way, but you try to find a more practical way and constrained by your resource, constrained by your training background, and constrained by the knowledge available in the literature or in the industry. And that's difficult also for investors. And investors said, oh, I have like $10 million. And where I put my money so that it has the best chance to be successful and hopefully will be better than the bank saving rate. Bank saving rate around days, it probably give you 4% roughly. And for those investors, they like to put into a certain areas that either he likes more or he like to have a higher rate of payoff. But typically, high risk will have a higher payoff. And different funds have different profile of risk. And for investors, many investors already put a lot of money in the AI research. And I think that every year we have 100 billions of dollars invested. And for developers, they probably would not be able to find best way. And they try to find a practical way that they can pursue. And the investors also limited in terms of the information availability. And they are not typically not expert in AI, but they try to find a direction that probably get their goal satisfied. For example, suppose, I have a lot of money, like Paul Allen. Paul Allen has a lot of money, and he wants to put into a direction. In his case, he invested in neuroscience. That's his way of spending his money. I don't think Allen was spending his money in the best way. You say best way. Because they probably create more jobs, but create jobs in neuroscience is that what he wants? Because we have many jobs in neuroscience in the United States, in Europe, in China, in Japan. There are many, many countries that have neuroscience jobs. Do we want to spend the money to create more jobs? I'm not sure. So your question is difficult.
Would you be willing to share with us how you dealt with the post-selection issue in your research?
That's probably a very good question, and we probably can talk about that in the later episodes.
And finally, what advice would you give to stay away from this issue in works and in industry? What would be your advice?
So in terms of the post-selection misconduct, unfortunately, almost all AI publications, I say almost all, are doing post-selection. That it's probably natural. It's like you want to regret your move. That's very natural. And when nobody is around, and you regret many times. And that's a kind of magnet you attract to it. And it's very difficult to get around this habit. Very difficult. And the problem is that every time you get a new problem and you regret a new system, and then you really never solve the problem. So suppose I have 100 decisions to make. If I regret in the middle and I change my system, but my later system is not able to answer the earlier problems. Do you see that? Suppose I have an earlier problem, the system finally solved, But once I have a problem for this new problem and I switch a new system, that system will not be able to answer the early problem that early system already solved. You see that? So it's like endless nightmare. So how do we solve the endless nightmare? We need knowledge in neuroscience, psychology, biology, computer science, electrical engineering, mathematics, maybe including in physics. And that is what our channel is for. We will explain for laymen. You don't need to have knowledge in all those disciplines, but we try to give popular science ideas and everybody can understand and investors can also understand so their money can be better spent in the future.
All that sounds really exciting. Dr. Wang, thank you for your time and thank you for all the advice you gave us here.
It's my pleasure.